This is worksheet 6 of the moles packet, and this worksheet does not actually introduce new information. What it does is it puts everything together. So at this point we know 3 definitions of a mole. A mole is equal to a molar mass, which we have to calculate individually for each compound or atom, and gives us an answer in grams per mole. We know that a mole is equal to an Avogadro's number of atoms or molecules, 6.02 times 10 to the 23rd. And we know that for a gas, a mole is equal to 22.4 liters, assuming that we're at standard temperature and pressure. So if you look at the chart on this worksheet, which is the exact same as the chart on worksheet 1, if you can convert whatever amount you're given, whatever unit you're given it in, to moles, you should be able to get from moles to grams, moles to molecules, or moles to liters, using the 3 definitions. So I want you to think of moles as the center of this diagram, okay? And this is going to be important because the challenge of this packet is that everything is mixed together. So if you look at the first example here, it is giving us an amount in grams and asking us to find the volume in liters. So what that means is we are starting here and we are asked to end here. And I want you to try to think about these problems using this chart and using this chart to plan out your path on this worksheet, because you will have this chart on your test, and because some people have gotten into the habit on previous worksheets of always relying on the example at the top of the worksheet. But when you get to your test, you're not going to have examples of how to set these things up. So you got to start being able to think through this without the example. This chart will help you do that. So I'm going to erase these little lines that I had when we were talking about the definitions, so that we can just focus on this problem at hand, example 1. So if I want to start at grams and get to liters, there is no arrow that takes me directly from grams to liters, right? So that's what tells me that this is not going to be a one-step problem. Instead, what I need to do is go from grams to moles in one step, and that means I'm going to have to calculate a molar mass for, in this case, neon, so that shouldn't be too hard. And then I am going to need to go from moles to liters, and that's not any special calculation because I can use the 22.4 liters of gas being equal to 1 mole. So if you look, that's exactly what we've done. We wrote out that we want to find liters. We were given the 40.36 grams in the problem, and then we set up our picket fence so we can keep organized what's on top and bottom. Okay, and so the first thing is we wanted to get rid of grams. So to get rid of grams, I have to find a molar mass. Now, if you look at neon, it's just 1 neon atom. So on the periodic table, in neon square, it says that 1 mole of neon is equal to 20.18 grams of neon. So that's what I'm using in this first fraction here. And I put grams on the bottom so I can cancel out my units. If I solve the problem right at this point, I would have my answer in moles, which is not what I want. But it means I've gotten myself to this point on the chart here. So I've taken care of that first step. Now I need to get from moles here to liters, my ending point. And so I'm going to use, again, like we talked about, this 22.4 liters of gas. Right, and that's what I did here, and I put moles on the bottom so I can cancel it out, which means I end in units of liters. So I multiply my 40.36 by 22.4 and divide by 20.18, which gives me my final answer of 44.8 liters of neon. All right? Okay, so you kind of see how we're using this chart, right? So what I want you to try is I want you to try on the next one to see if you can continue to use the chart. So this time we are trying to go from liters to molecules. So now my starting point is liters, right? And my ending point is molecules. So this time, I'm going to actually have to kind of reverse my direction, right? The very first thing I'm going to want to do is use that 22.4 to go from liters to moles. And then the second step is going to get me from moles to molecules. Again, I know this is not a simple one-step problem because I cannot go directly from liters to molecules. There's no arrow on my diagram allowing me to do that. All right, so let's see what we did here. I want to find molecules. I'm given liters. I will create my picket fence. So my first goal is to get from liters to moles, right? So I'm going to use my 22.4, liters being equal to 1 mole, put liters on the bottom so I can cancel it out. I don't want my answer to be in moles, which is what I would have if I solved right now, right? But that means I've gotten myself to my center of my chart, so now I need to go from moles to molecules, and I'm going to use Avogadro's number. I put moles on the bottom so that I can cancel out, and now I'm left in molecules, which means I am ready to solve, making sure that I'm putting the 6.02 times 10 to the 23rd in parentheses, and getting a final answer of 1.51 times 10 to the 24th molecules of carbon dioxide. So, this really isn't introducing anything new, it's just putting it all together. And this worksheet is going to tell you if you're getting to the point where you're going to be ready for the test. Because worksheet 7 is just more review. So do you notice that I've bolded what you're given and what you're trying to find to help you really focus in on the important points, and we will work on these problems when you get to class.